The placement of fluid system components in relation to each other is critical to successful operation of the system. Fluid naturally flows from areas of high pressure to areas of low pressure. Pumps operate by creating low pressure at the inlet, which allows liquid to be pushed into the pump by atmospheric or pressure head. Pressure head, also called static pressure head, static suction head, or static head, is created when the reservoir is placed at a height higher than the center line of the pump and is the measure of distance from the pump to the tank. This creates a positive inlet pressure and helps fluid flow to the pump. Most pumps will tolerate only a small amount of positive inlet pressure, usually less than 15 psi, so elevation of the reservoir should not exceed 10 to 15 feet above the pump. If the reservoir is placed too high, the increase in inlet pressure can blow out the shaft seal of most pumps. If the pump is mounted higher than the reservoir, the height from the fluid surface to the pump inlet is called the suction head. If pump suction is used to elevate the fluid, suction head should be kept to a minimum to prevent generation of a vacuum effect on the pump inlet fluid. Several issues may occur if enough fluid does not flow to the pump inlet. One such scenario is called cavitation. The most common form of cavitation occurs when the inlet fluid is not entirely filling the cavities which open up for it on the pump inlet. This type of cavitation is called vacuum cavitation, a condition commonly known as starving the pump because not enough fluid makes it to the inlet. The lack of sufficient fluid can be caused by a clogged inlet, a dirty strainer, too large a suction head, too long a plumbing run, restricted or collapsed plumbing hoses, or too viscous a fluid, such as when the temperature drops and oil thickens. Cavitation causes a drop in pressure at the pump inlet. When the pressure at the pump inlet drops below the vapor pressure of the liquid, vapor bubbles form and the fluid appears to boil. When the bubbles collapse, they can damage the pump by removing small pieces of metal. This is called pitting and can cause permanent damage to the pump. Another form of cavitation is called aeration and is caused by air entering the oil stream. This can occur for a variety of reasons, including a low oil level in the reservoir, leaks in the inlet plumbing line, especially at unions and joints, and worn or dislodged seals in other hydraulic components such as pumps, cylinders, or valves. Cavitation is often characterized by loud noises, such as grinding or as if there are marbles in the pump, and pitting damage to parts as material is removed by the bubbles. If fluid systems are properly designed and properly maintained to prevent dirt or air entering the system, operation will be efficient and reliable.